Hi ladies, this is lesson 10.2 and this is dealing with two special right triangles. So we're going to specifically look at triangles that have 45, 45, 90 degree measures and triangles that have 30, 60, 90 degree measures. So these, again, they're both right triangles, but one has two 45 degree angles and another one has 130 and 160 degree angle. So to start off, remember an isosceles, a triangle with measures 45, 45, 90, where these two angles are the same measure and it's a right triangle. That's an isosceles right triangle. So let's look at the Pythagorean theorem to find the hypotenuse of these three specific triangles. So in this first one, we're going to look at a squared plus b squared equals c squared. So 1 squared plus 1 squared is 2. So the square root of 2 is equal to c. Now with some of these, you have to remember your properties of radicals from algebra. But let's take a look at the second one. The second one has a side length of 2. So that's 2 squared plus 2 squared equals c squared. So 2 squared plus 2 squared is 4 plus 4, which is 8. So c is equal to the square root of 8. Now the square root of 8, if you remember your properties of radicals, is the same as the square root of 4 times the square root of 2. The square root of 4 is 2. So we can simplify the square root of 8 as 2 times the square root of 2. Now in the third one, we have side length of 3. So to find the hypotenuse, we have 3 squared plus 3 squared equals c squared, or 9 plus 9, which is 18, equals c squared. So c is the square root of 18. Now again, remember your properties of radicals. Square root of 18 is the same as the square root of 9 times the square root of 2. 9 times 2 is 18. The square root of 9 is 3. So is there anything that you recognize as a pattern with those three triangles? They are all isosceles right triangles, which means that these angles are both 45 degrees. So in an isosceles right triangle, if the legs have length L, then the hypotenuse has length L times the square root of 2. So in the first one, we have 1 times the square root of 2. In the second one, we have 2 times the square root of 2. And in the third one, we have 3 times the square root of 2. So that's our first special right triangle. Now let's look at a second one. The second one has angle measures 30, 60, 90. So in a 30, 60, 90 triangle, if the shorter length has side A, so the shorter length is going to be opposite of the smaller angle. So the shorter length is side A. The longer length, B, is going to be A times the square root of 3. And the hypotenuse, which is the side opposite of the right angle, has a length 2 times A. So let's look at an example that deals with both of these. So in this example here, we have a 45, 45, 90 degree triangle. So let's look at that one first. The question is to solve for x and y. So looking at this 45, 45, 90, we know that this side is also 14 meters because it's an isosceles triangle. So if the base angles are congruent, then the sides are congruent. And the relationship between the hypotenuse and the legs in an isosceles right triangle is the length of the side times the square root of 2. Now in the second triangle, we have a 30, 60, 90 triangle, but we already know that this side is 14 times the square root of 2. We know this is the shorter side, and we know that this angle is 60 degrees, which makes this x the longer side. So first, let's look at the relationship in a 30, 60, 90 triangle between the hypotenuse, which we know, and the shorter side length. So the shorter leg has the length A, and the hypotenuse has a length 2 times A. So if we're looking for this, A, we can relate it to the hypotenuse, which is 14. So 2 times A is 14 times the square root of 2. So in order to just solve for A, we can divide both sides by 2. And we're left with A equals 7 times the square root of 2. Now we're not really looking for this, but we do need that side length in order to find x. So now we know the shorter side length, we know the hypotenuse, but we're really looking for the longer side length. So in relation to A, the longer side length has a length of A times the square root of 3. So in this case, we have 7 times the square root of 2, that's our A, and then our longer side length multiplies that by the square root of 3. Now, multiplication is commutative, so again, if you remember your properties of radicals, that's 7 times the square root of 2 times the square root of 3, which is 7 times the square root of 6. And that's in meters. So that deals with both the 30, 60, 90 and the 45, 45, 90. So let's look at one more that again deals with both of these triangles. So in this triangle, we know that the shorter base has 6 units, that's labeled RU or TU, and then the RU segment right here is 14, which is also labeled. And the measure of URS is 30 degrees, which is labeled, which means this is 60 degrees because this is a right angle. So again, here we know the hypotenuse, it's 14 centimeters. This would be our shorter side, this would be our longer side. So the shorter side, or the hypotenuse, is equal to 2 times the shorter side. So we know that A is equal to 7, and B is equal to A times the square root of 3, which in this case is 7 times the square root of 3. So we have B. Now this side here is also going to be 7 because it's a trapezoid. So we know that these two lines are parallel. And if those two segments are both perpendicular to the base, they have to be the same length. Okay, so in our 45, 45, 90 triangle, we know that each of the legs is 7 units. And then since these are both 90 degrees, these two lines are parallel, which means this also has to be 6 units. So now we have 7 times the square root of 3 plus 6 plus 7. That's the length of our entire base here. So 7 times the square root of 3 plus 13. And you can leave it just like that. That's the exact answer. And it's in centimeters. So please jot down any questions that you have, and we'll go over them next time in class. Thank you.